Hi everyone, my name is Javier Lopez and I'm lead bioinformatics engineer at Genomics England, and I'm here to talk a bit about the learnings from Genomics England's experience in developing whole genome sequencing analysis pipelines to support a national-scale genomic medicine service. So what this presentation is about is mostly about the challenges that we've been finding while transitioning our pipelines from supporting a research project such as the 100,000 Genomes Project to actually supporting the Genomic Medicine Service of the NHS. So from being a research project to actually being a platform that offers us a clinical service. And as many of you might know, when you are especially developing pipelines within an academic environment, your focus is primarily on functionality, right? Just make it work. And of course, reproducibility. But there's typically less focus on things like sustainability, scalability, durability over time, performance, and robustness. However, these items are key when you start offering a service, and in particular a clinical service. So here I would like to touch upon the following areas which are directly linked to these concepts. So I would like to touch upon performance, development, and establishing best practices within the team, technology debt, and regulation, the regulation that all of our healthcare systems are subject to. If we start with performance, as you can understand, this is key to achieve the required throughput of process samples. And I've here drawn this plot to give you an example of the throughput that we need. So on the x-axis, you can see date, it's actually month, and in the y-axis, you can see the sample counts. So at the moment we are processing, as you can see, somewhere between 2,000 and 3,000 samples every single month. Main bottlenecks in our pipelines have to do with the processes of mapping, variant calling, and variant annotation. We've already been taking actions on these. So years ago, for example, Genomics England adopted Dragon Illumina technology to deal with mapping and variant calling. But still, it's a limited resource, right? Since it's a very specialized hardware. So you only have so many Dragon boxes that you can run, say, for example, 50. And if you have to run 900 cases that week, well, this can become a bottleneck. On the other hand, we have variant annotation, which, there's already a discussion at Genomics England on what's going to happen with this. We are currently based on a centralized service, which brings great benefits, but it's a computational expensive process. So there's definitely a conversation going on whether we should actually decouple the sample processing runs by using some other strategy or tool. As I said, this is currently under discussion. With a growing team over the last couple of years and people now spread over 7 different squads, different work streams, this immediately brings operational challenges, and it becomes immediately apparent that we need consistent approaches on different things, from algorithm, software design to documentation, versioning, and so on. And therefore, we are currently working on developing some best practices guidelines. Regulation, as you can imagine, Genomics England's pipelines are under strong and strict regulation. All our software is accredited with the UK's in vitro diagnostic medical device accreditation, and this impacts everything that we do, literally everything that we do. So all processes are subject to some sort of SOP, either if they are deployments or development of new features or bug fixes and so on and so forth. Everything needs to be comprehensively documented and traceable. And of course, testing, as you would like from a medical device, needs to be exhaustive, and it's of vital importance. So we have defined 3 formal testing phases that you can see in your screen. And for example, all our unit tests need to achieve on 90% of line and branch coverage. We got integration testing on our regression phase. We run up to 200 real cases every single time. And well, these 3 phases need to be signed off for any new change to make it to the production environment. This, as you can imagine, represents a burden that impacts our ability to progress, our agility to progress and to release. And at the moment, while we've made great progress over the last couple of years, and at the moment our release cadence is around 3 months, but we of course have to improve this. I would like to highlight on this and on trying to speed up and make more efficient the testing phases. We have an initiative that we call Tiny Genomes, which has to do with developing synthetic data sets that enable test coverage of all functional features in a timely manner. So these are synthetic data sets that we want them to run end-to-end from our pipelines in less than an hour. A real case will run cancer rare disease somewhere between it will take somewhere between 10 to 24 hours to complete. So here you have the time profile over different steps in the pipeline. This is a real sample, and these are 2 of the synthetic data sets that we built. And this brings, well, lots of technical challenges to manage to achieve these synthetic data sets, or to get these synthetic data sets. So to conclude, it's a significant change to transition from pipeline development for our research project to supporting a clinical service. We have touched upon some of the challenges that we're facing that have to do with performance, consistency, technology, regulation, and testing. We've done great progress on this, yet of course there's room for improvement, while we have to of course maintain and keep exceptionally reliable data results. With this, I conclude my presentation. Thank you very much for listening. And these are 2 posters that we are presenting at ISMB. Please do reach out to us should you want to discuss further details or simply have a chat with us. Thank you very much.